Today we will discuss sum of subset problem. Given n positive integers and m, find out subsets whose sum is m. For example, our set S equal to 11, 13, 7, 24, n equal to 4 and m equal to 31. Okay, which are the subsets? 11, 13, 7, which will create a sum 31. 13 plus 7, 20, 20 plus 11, 31. And you will get another set 7 and 24. 24 plus 7 is equal to 31. So these are the desired subsets. So how can we find this? And how can we represent the resultant subset? We can represent the subsets as a list of indices of elements. That is one way of representing the resultant subset. That is, our array is 11, 13, 7, 24. These are the elements index 0, 1, 2, 3. 11, 13, 7. This is one combination. So this can be represented as 11, 13, 7. This subset can be represented as index of 11 is 0, 13 is 1 and 7 is 2. This way we can represent, and 7 comma 24, this subset will be represented as index of 7 is 2 and 24 is 3, 2 comma 3. This is one way of representation. The another way is fixed sized array. That is, we have 4 elements, so the resultant array should have 4 elements, 2, 3. Then in this 11 we have used, that is its index is 0. So an element with index 0 is used, and an element with index 1 is used, and an element with index 2 is used. 24 is not used, so its index is 3, we will put a 0 there. Okay. Similar way, this can be represented as 0, 1, 2, 3. 7, 24. 7 is index 2. So an element with index 2 is used, and element with index 3 is used. 0 is not used, 1 is not used. So in these ways we can represent the resultant subset. This is called, the first representation, it is called variable size tuple solution or formulation. The second method is called fixed size tuple formulation. In this way, in these two ways, we can represent the output. Then how can we find the subsets? Let us use the brute force method. In this brute force method, first let us consider the elements with single element, the set with single elements. We will be getting single size sets. Eleven, 13, 7 and 24. These are the single element subsets. Next, let us consider the two element subsets. See, subset sum is not equal to 31. Here not equal to 31. Here not equal to 31. Here also sum is not equal to 31. Next, let us try two element subsets. So it can be 11, 13, one subset, 11, 7, another subset, 11, 24, another subsets. That is, in all the subsets, first element is 11. Next, let us try the two element subsets with 13 as the first element. With 13, 7, another subset is 13, 7. Then 7 as the first, see 13, 11, no need to consider because it is already considered. Then starting with 7, it will be 7, 24, 7 comma 24. 7 comma 11 no need to consider because it is already considered. 7 11 7 comma 13 it is also considered. Then starting with 24, 24 11 no need to consider, it is already done. 24 13 already, sorry, 13 24 it's done. Then 24 7 it is already done. Okay, then three element subsets. It can be 11, 13, 7, one subset, 11, 13, 7, one subset, then 11, 7, already we have 11, 7 and 24, another subset, then 11, 24, 11, 24, 13, 11, 24, 13, 11, 13, 7 and 11, 13, 24, okay, 11, 13, 24 and 11, 7, 24, 11, 7, 24, 11, 7, 24. And okay, then with 13, 7, 13, 7, 13 as the first element, 7 as the second element, 13, 7, 24, you will be getting one set. And 13, 7, 24, 13, 7, 11, 13, 7, 11, 13, 7, 11, it is already considered. Okay, no need to go for that. So 13, 7, 24, then 13, 24, 11, 13, 24, 11, yeah, 13, 24 is already considered. Then 13, 24, 7 and 11 both are considered. Then 7, 24, 7, 24, 11. Again 7, 24, 13. These are the possibilities. 7, 24, 11. It is already considered. 7, 24, 13. It is also considered. Okay. Then this so the 3 element subsets are over. Next, let us try the 4 element subsets. It is 11, 13, 7, 24. If what is missing in this 11, 13, 24 is 7 is missing, but it is already considered. Okay, so this is the only 4 element subset. So these are the subsets. Then how many subsets give the sum 31? Here you can see 13, 11, 13, 7 gives the sum 31, and here 7 and 24 which gives a sum 31. So you are getting two subsets whose sum is 31. Okay, this is the brute force method by which you can find out the subset. How many subsets we have to consider? We have to sum up all the subsets. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 subsets we have to consider. That is nearly 2 raised to 4. Then only we will get these two subsets. Next, let us discuss the formation of the subsets. How can we create these subsets? Okay, some algorithm for that. So let us rewrite these nodes once again, these sets once again. So 11 you are getting, then 13, then 7, then 24. These are single element subsets. Next, let us consider the 2 element subsets. They are 11, 13, 11, 7, and 11, 24. Next, with 13, you are getting 13, 7, then 13, 24. With 7, you are getting 7, 24. And with 24, there is nothing. Okay. Then let us consider the 3 element subsets. Okay. So you are getting 11, 13, 7, and 11, 13, 24, and 11, 13, 24. Okay. And 11, 7, 24. Then with 11, 24, there is nothing. Okay. So then with this 13, 7, with 13, 7, you have formed 13, 7, 24. And with 13, 24, nothing you have formed. Then here there is no 724, there is no 3 element subset here also. Okay. So then next consider the 4 element subsets by adding 11, 13, 7, and 24 we are getting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. If I consider each subset as a node of a tree, I can construct the tree like this. This is the root node, and these are the first level elements, these are the second level elements, and this is the third level, and this is the fourth level. Okay. Once again, I will reconstruct the tree. By summing up these elements. So this node, it will be represented as 24 because the sum of 11 and 13 is 24. So starting from the root where sum is equal to 0, sum equal to 0, then 11, then 13, then 7, and last the 24. Then coming to the two element cells, I'm getting a sum 11 plus 13, it is 24. That is, by considering the 11, I am getting a sum 11 here, and by considering 13, that is 11 plus 13, I am getting a sum 24. Then next node will be 18, that is 11 plus 7. Okay, then next node will be this one, 11, 24. So it is 35, that is 24, and I have considered 11 plus 24, this is 35. Then three element nodes, I am getting 11, 13, 7. So sum is 31. 31, and that is by considering 7. 11, 13, 7, then one more element is remaining, that is 24. I will consider 24, then I will be getting a sum 11 plus 13, 24 plus 24, it is 48. It is 48. Then 11, 7, 24 is coming from this. 24, if I consider 24, 11, 7, 24. What will be the sum? 11 plus 7, 18, 18, 18 plus 24, 42. I'm getting a sum 42. Then that's over. Starting with 11. Then there comes starting with 13. Okay, 13. We are getting a node by considering 7. So we are getting this node by considering 13, that is 0 plus 13. Then 7 we are getting a sum 20. Then 13, 7. See, our array is 11, 13, 7, and 24. So 13, 7 we have answered, and 13, 24 is remaining here. 13, 24. So it is 13, 24. What is 13 plus 24? It is 37. is 37, and with 7 we have 7 and 24, one subset. So this node will be 7 plus 24, it is 31. 24 there is nothing. Then we will consider the next level, that is 4 element subsets. So 31, what is remaining? 24 is remaining to consider. We are getting a sum 31, 24, 55. 55. How many nodes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. One is missing. 8, 7, 11, 7, 24. Okay, 11, 13, 7 and 24. Okay, 13, 7. Yeah, here one is missing. That is 13, 7, 24. We have not considered. Okay, so one more no. 13, 7, 24. This one. This one, 13, 7, 24. 13, 7, 24. What is the sum? 20 plus 24, it will be 44. We can see this node gives a sum 31, and this node gives a sum 31. Okay, this is actually the state space tree of variable tuple formulation. This is the state space tree of variable size tuple formulation. Here any node can be a solution state. Any node can be a solution. Then what is the other method? So that means the problem